I'd like to introduce you to Chang, CEO and co-founder of LanceDB, and he will be coming up here and giving you a great talk, and I hope you enjoy. Have a great day, everyone.
Okay, I'm really excited to be here, and looking at all the suckers the organizers tricked into coming on a Saturday morning to hear me talk. So it's a little bit of an echo, but maybe I'll try to stay far enough. Anyways, quick show of hands. How many of you use agents on a regular basis? And how many of you have created an agent? All right. Okay, there are a few. Great, awesome. So we'll have a good mix today. So quick self-introduction here. My name is Chang. I'm the CEO and co-founder of LanceDB. We're the AI-native multimodal lakehouse. I've been building data tooling for machine learning and AI for about 2 decades at this point. I was one of the original co-authors of the Pandas library. I spent a bunch of years doing big data warehousing stuff at a company called Cloudera. And then I moved on to machine learning and recommender systems at a streaming company called 2BTV. And today I'm working on LanceDB to reinvent data infrastructure for AI. Okay, so how many of you remember that talk from Jensen saying how 2025 will be the year of the agent? Okay, a bunch of you guys, right? I think Sam Altman said the same thing, right? And what's also really interesting is if you look at, we were a Y Combinator company. If you look at YC batches in 2025, more than half the companies are agent companies. So agents are everywhere, and maybe we should learn about them. But you say, hey, I don't really care about being popular. Why is this important? So my statement here is that agents will change everything. It will change not just kind of the software that you're using, the specific interactions you have with it, but also our daily habits. If you've been paying attention to tech news in the last week or so, right, you've seen a bunch of news around how Amazon is suing Perplexity to stop them from their comment browser from buying things on Amazon. Have you guys seen this? Yes, some of you guys, right? And so maybe you've seen the clapback, Perplexity CEO saying something about this is trying to stifle innovation. Right? But what's the underlying logic here? Why does Amazon care whether Perplexity is helping their Amazon users from buying stuff? Right? If anything, more stuff gets bought. Why would Amazon be unhappy about this? So there's the ads, right? There's also, right, Amazon has invested a lot in the recommender system and the search systems, and those all become useless, right? And Amazon is no longer are able to work with smaller vendors, and it becomes, from their perspective, kind of a disintermediation, right? So it becomes Amazon makes a lot of the money and has so much market power by being the platform. And Perplexity, by coming between the Amazon platform and the user, they now become the new platform. So when done right, agents really does have the power to change everything. Okay, so we've established that agents are kind of everywhere. They're super popular, and that really we've seen evidence that they are actually important, and we should care about them. So what is an agent? And let's have a quick formal definition here. All right, so a popular definition is an AI agent is a software system that can perform tasks autonomously. And when we look at this definition, it's kind of simple, right? Aren't all software systems autonomous? You run the code, it does something, and you're done, right? But let's take a look at these 3 words: perform tasks autonomously. So typically, the task will be given by the user as a query, right? And then the agent will turn that through a prompt into instructions for an LLM or for tools. It will use an LLM for planning and reasoning. It'll break down the tasks that from the user query into multiple steps, sub-problems. It can use the LLM to help break that down, plan different tasks, and then reason about how to go about these tasks. And along the way, the agent will have a big toolbox. One is it'll have tools, and these can be third-party APIs or functions it can call or other applications. All right, and these are things that it'll perform actions on. And then the agent will have knowledge and context and memory, and it'll have its own state. And so here we'll use retrieval, and it will use search to deal with all of that knowledge base. And actually, that retrieval is what we're going to be really focusing on today. So far so good, right? Agents have a huge impact on the world. We see agents everywhere. And agents, we've defined them as autonomous systems that they can take action, number one. Number two, they need data and the context, or at least data and context can help them perform their tasks much more successfully. And number three is that they can actually break these tasks down and plan subtasks and reason about these things. Okay, so where's the alpha, right? So when you create these agents, everyone has the same access to the same LLMs. Everyone has pretty much knowledge of the same techniques, right? The techniques are just, you go to a meetup, you learn about something new, and you can just implement it. So nothing's secret there. So what really differentiates your AI features from that of your competitors? Right, we got to guess. Yeah, so if there are any Star Trek fans in the audience, hopefully you would have gotten the hint, right? The answer is data. Specifically, it's your data, because that's really the only thing that's proprietary about your AI feature. So the better you can connect your data to your AI agent, the more differentiated it becomes. And to me, that's the critical difference between sort of just like a me too, oh, I just need to sprinkle some AI magic and so I can go raise money, from like, hey, this thing's actually useful and it can actually work in production. Unfortunately, I think the data infrastructure world is not really ready for agents that do search. How many of you come from background of like search or recommender systems, machine learning, and that kind of thing? Okay, a few. And so you're probably wondering, like, we have search engines, we have vector databases, like, why are agents different? And I'll spend a little bit of time telling you that. Okay, so any fans of like the Dwarkesh podcast in the audience here? Okay, cool. And if you guys haven't seen it, the episode with Karpathy is really, really good and just came out recently. So Karpathy talks about agents a lot in this episode. And I think there was a joke about how like 2025 isn't the year, it's not the year of the agent, but it's like going to be like the decade of the agent. Except he was expressing a negative sentiment in that his prediction is that it might take a decade for agents to actually become autonomous enough and work really well. I think there are a couple of snippets that are really, really interesting that I want to pick out. So number one, he talks about how agents are not multimodal enough. And then he talks about how you can't just tell agents something and they'll remember it, right? So let's break this down. What does that really mean? So number one is that agents should be multimodal. Basically, one is being able to get data from a lot of different sources and understand a lot of different modalities of data, right? But number two is when it takes action, it needs to be multimodal. So like, yeah, it needs to be able to like use a computer really successfully, and that can be visual as well as by via code or just via structured text. And then number two is, you can't just tell an agent something and have them remember it, right? There's something lacking in the way that agents deal with like memory and context and knowledge bases. So let's kind of break them down. So I think number one is that agentic search is just much bigger in scale. So when we do search as humans, we're kind of limited by manual typing speed, right? Like maybe some of you can type at like a couple hundred words per minute, but agents can do much better, right? So we're sending one search query at a time, getting results back, and kind of like exploring that. And at least like my brain, I have a one-track mind, right? I look at I do one search, I look at some results, and then like if it goes past 5, I start paying attention. Whereas an agent can issue dozens of parallel queries to explore the search space, and then to be able to quickly refine those results and get much better results and much more relevant results. So now you've gone from a lot of agent applications. I see that like, hey, we need to do search at maybe like 10 queries per second or something like that at max, to okay, now we have a single query can result in a user query can be broken down into like 100 parallel requests that all have to execute at the same time. So scale is much bigger. Multimodal also means more sources. Typically, when you think about like data sources, maybe this is like some kind of database in tabular land, like Postgres, or like your Snowflake, or some sort of like structured database thing. But when you talk about multimodal data, the number of sources that you have to deal with really explodes. So this is just a small sampling. This is like 1/100th of what you might encounter in like an enterprise data storage stack, right? There's like SharePoint, there's Notion, you've got your Notion docs and all the like Atlassian tools, all the Google G Suite tools, YouTube videos, Slack, Dropbox, right? And then like your other tools like storing your like sales calls, your legal documents, and everything. You can get multimodal data out of all of those sources, and those all contain really valuable business data that potentially can be used by your agent. So dealing with these sources are much more complicated, and making them searchable is more complicated. So on the flip side, now that you have some multimodal data, the way that you work with it becomes more complicated as well. So one is like, let's take an image, right? This is a painting. So one way to describe this painting is a literal description. There's a house, there's a road, there's a couple of trees, there's some grass, right? And another way is you could describe it in an artistic sense of like, what era was this painting? What kind of mood does it put you in? Like, what style of artwork is this? And then you might describe things like, what kind of color profiles is it? Is it like, is it grayscale? Is it monochrome? Is it like super saturated? You can talk about different image features and kind of embed these images. And then, of course, you can turn the different descriptions into embeddings or keyword search and full text search indices to search along that. So you've got a ton more features now, right? So instead of saying, okay, I have a piece of text, and then I'm going to embed the text and search that, I have a piece of image, and now I can extract 5, 6, 7, 8, 9, 10 different types of features out of that same piece of multimodal data. And then, of course, with all of these insights that you actually get out of your multimodal data set, that data set becomes much more enriched for your agent. And then the question is, okay, so you have a user query coming in, right? And it's going to ask you some questions, or you need to do some search. So which feature do you actually search on, right? And then when a user asks a question, like what part of the user query is talking about like a literal description of that image versus an artistic description? And how do you know, like, should I search on image or should I search on the text? Should I do keyword search? Should I add filters? Like, there's too many things and too many features and too many dynamic matching to do here for us to code it by hand, right? So to really get to the bottom of user intent, one trick people are using is like a LLM as a classifier, and that turns into a query router. So when a user comes in, instead of having manually written rules to say like, okay, you go to this feature or that feature, we actually ask an LLM to be a semantic router. You can parse that query, rewrite it, and then say the LLM can help you figure out, okay, which ones might be exact keyword matches, which ones are similarity matches, and which ones talk about things in a literal sense versus an artistic sense, and just different matches for different features. Okay, so we talked about scale, we talked about multimodality, and when we talk about scale, one of the things that I mentioned is, right, like an agent can run like a massively parallel query where you have one user query that gets broken down into like dozens that explore the search space. So the problem is like it's like it breaks it down to like 10 queries, each one gets like top 10. Now you've got 100 results back, and so maybe that breaks down and it's much bigger than the context window, or like you have 100 results. You're not going to present them to user, right? Like, God forbid your user me, and like if I have to scroll past like the first 5, I stop paying attention. So agentic search has to be iterative. It's not, and you have to shrink down that search space. And it's not only that, as you break down your tasks into subtasks, right? Each step will also require some refinement, some search. So over time, it's very iterative, and you might fan out massively in the beginning, but then you need to quickly then refine that search, but keep searching. So it's no longer one and done like what we learned in the past couple of years about like quote unquote vanilla RAG, where you have a prompt, that prompt directly goes into the knowledge base, you get some context back, you shove it into the prompt, and then you send it off to the LLM. So it no longer works like that. And so what problems does that bring up here? So I think if you keep watching the podcast, right, you'll come up on this part as well. So Karpathy says, every time an AI performs an action, there's roughly a 20% chance of error. Well, I think 20% is like, we can nitpick on the numbers, right? So we can do lots of tricks to shrink that down, but there's not 0 chance, and it's a significant amount. So at every step, there's like some chance of error, and so if you need to complete 5 actions or you have a sequence of like 10 steps, those things accumulate, right? Those error rates actually accumulate. So now you go from like an 80% success chance of success to like a roughly 30% chance of success. So what are the tricks we can do to deal with that? So this is where a couple of things becomes really important. Number one is that the search has to be really performant, right? So if, let's say every step you're performing a search, and with like one step vanilla RAG, like your search is, I don't know, 1 second or like 2 seconds. It's not the end of the world. Like you see a spinner for a second and you get some results back. But if it's now like 5 steps, 10 steps, and you're searching through a really large corpus, each one takes a bunch of time. Now you're talking about 10 seconds, 20 seconds, or sometimes like minutes if the agent's really complex, right? And so, then that no longer becomes interactive. I think in the very beginning, folks were, fine with that. They were like, okay, deep search agent, like I'm just gonna, what I'm gonna do is just like run the search, and then I'm gonna go get coffee, and then I'm gonna come back, right? So then like agents running, like if you, I don't know if you guys will see, or like are fans of like XKCD. There's like the one that one of my favorite is like always like code's compiling, and that's the main reason why like programmers are not productive, right? And so like my agent's running is now my code's compiling. And there are various tricks that people use to deal with that too, which is like, okay, instead of like just dealing with one agent, trying to do that, make that interactive and complete one task, I create like 5 tasks, and I'm like switching between different agents, and I'm doing a lot of multitasking. And that'll sometimes work, but then you get distracted, and you're dealing with this one agent, and then you have to do context switching, right, into another agent, and it's not always good, and you kind of lose track doing a lot of context switching constantly. So performance becomes really important for search. Number 2, the error rate becomes higher and it accumulates. So what it means is that evals become a lot more important, right? So every time you make a change, because of the complexity and the interactions, you want to make sure you're actually improving things overall. And you're not doing like a whack-a-mole where you make a change, it improves things in like step 5 of the agent, but like then screws things up in step like 8 or like step 2. And I think fortunately with evals, it doesn't have to be super complicated, right? Like most of the time, in our community, what we've seen is you get really far just by looking at the data and have like a good set of curated eval data set with like 50 observations or 100 observations, and that gets you really, really far. Okay. And then number 3, because of all of this, right, that means agents are doing lots of exploration. So you might take a path and you go down it a couple steps and you find, okay, that's actually wrong, I have to backtrack. And then I have to like have some flexibility to be able to find the right path. So managing the agent state as you go through that exploration process becomes super important. So it's not just about search anymore, but I have to do like key value fetches, right? I have to maybe the agent state is stored in this like big JSON blob, and I have to say like fetch me the state for this agent in this execution run at this time or at this step, and then I have to be able to backtrack. So to be able to keep track of different versions of that agent state and then be able to do like time travel, that's super important. Okay, so let's summarize like all the ways in which data infrastructure is not ready for agents. One, agentic search needs to be multimodal. We need to support much bigger scale. We need to deal with a lot more features that we extract for the agent. We need to deal with a lot more search modalities. And finally, we need to be iterative, not just one and done, right? So tons of problems, how do we solve it? So I think number 1 thing is the solution is not another vector database. I think a lot of these problems are kind of foundational, and I guess my point to you is foundational problems require foundational solutions. Part of the problem with vector databases is that they tend to, vector databases tend to support narrowly just vectors and not all of the metadata that you need to deal with like state management. Most of them are not versioned and tracked, so you can't really deal with reproducibility. Most of them don't support the multimodal data. Most of them don't support all the different types of query modalities that you needed to deal with. And then of course, a lot of the vector databases today, the design is based on sort of like Elasticsearch, shared nothing kind of architecture. And because it doesn't give you compute storage separation, it becomes really expensive as you scale up. Okay, So at LanceDB, we have an open source data format. We call it a lakehouse format that we think is the foundation for the solution, right? Lance is the new open source standard for multimodal data, where instead of having your agent's data in a bunch of different places, you might have like your JSON agent state in like MongoDB, and then like your vectors in a vector database, and then your metadata somewhere else. And then your raw assets, if it's multimodal, living on like S3, you can put all of that in one Lance table. So a real quick sort of ecosystem view in your stack. So if you think about, and how many of you are already familiar with or worked with like Parquet, Iceberg, and like data catalogs? Okay, cool. So you'll kind of be familiar with this kind of stack, right? So an enterprise stack or the lakehouse stack has from the bottom, object store, that's your storage layer, and then the format layer is where Lance lives. So we call Lance the lakehouse format because it spans file format, table format, and then catalog protocol layers. And then on top of that is catalog services, and then also compute engines. Okay, so we got agents that need to do search, and then we got a file format. Like, what do these have to do with each other, right? So let's take a look at the foundations here, right? The core for search, right, is random access. You need, well, two things. One is you need to have a search index. So given a user query, you need to find like where are the closest matches in your data. Then you need random access so that you can actually quickly fetch those rows in your data. And then of course, you need to deal with large blobs, meaning if you have multimodal data, right? So if you look at a typical tabular data row, like if you are familiar with TBCH tables, TBCH table is like 100 bytes or so per row, right? Multimodal data is much, much bigger. So vectors are instantly an order of magnitude larger. Images, videos, you can get up to 5 or 6 orders of magnitude larger. So Lance, the file format level at Lance is more like, it's columnar like Parquet, so you can have fast reads and fast scans, but we can also deliver fast random access for search, and then we can deal with large blobs. So you can actually put all of your data together without having these separate systems. So that makes your search system much easier to deal with. You can consolidate all of the data. And then some of the really cool features about this, for those of you who are familiar with Parquet, is one, we have better readers and better I/O to speed up these scans. All right, and we've invested a lot in random access, and it's not just, hey, like I need to go quickly fetch this row. In AI, a lot of the data that you have to fetch, right, is deeply nested. So if you think about like agent state, for example, right, it's big blob and very deeply nested data. So if you're not careful, you have to spend a bunch of IOPS and hops to fetch like a deeply nested field. Whereas like with Lance file format, we've invested a lot so that we've limited the number of IOPS to at most 2, even for arbitrary deeply nested schemas. For multimodal data, we've gotten rid of row groups from Parquet so that because when you mix really small columns with really large columns in Parquet, the fact that it has row groups forces you into this trade-off. Either you're running out of memory because your row groups are sized for small columns, or your read performance really stinks because you've sized row groups for the large columns, right? And so if you need to support both random access and fast scans, then compression becomes harder. So we solve compression instead of having like file level compression algorithms, we use encoding. So FSST, dictionary encoding, run length encoding, a bunch of different structural encodings. Okay, so let's move one level up. So now we've got this, the file format, now we've got a table format, right? So a file format is basically, it describes within a single file how your data is stored. And a table format is, how do I put multiple files together to create a table? Because at the end of the day, all right, we want to think about our data in a structured format. So, hence the table format. So one is, okay, you can put all of your data in that same table. The Lance table format comes with a bunch of different indexes so that you can do all of the agentic search needs on that particular table. So you can do keyword search, you can do full text search, and then we have indexes for like SQL queries and key value fetches and things like that. The table itself is versioned. So as you add rows or you add columns, we automatically create different versions, and we allow you to time travel to say, hey, it's not just I search. If your agent gets a bad result, you can always go back in time and say, like, show me the result as if the agent was searching at yesterday at 5 p.m. right? And you can go back in time and restore the state of the table that the agent saw when the user experienced some bad result. Let's see. Yeah, and then one thing that I think that is super cool about the Lance table format is the ability for you to add additional columns, especially for multimodal data, without having to copy the whole table. This is actually a lot harder than it sounds. If you have tables like in Iceberg or other table formats, a lot of times when you need to fill in the values for a feature column, you have to copy a bunch of data. And if it's if your table is all floating point numbers, and it's narrow, maybe it's not the end of the world. But if you have a bunch of videos or images stored and your table is 10 petabytes, you don't want to copy 10 petabytes of data. And so. And this is super important for AI. Why? And it's super important for multimodal data because with multimodal, you can now extract a bunch of insights. And no one will know exactly what you need to extract from the get-go. So most of the time when you're developing these agents, you are incrementally enriching your data set and incrementally adding to your table as you go along. So this becomes super important as well. Cool. Yeah, and so one thing I didn't mention is the secondary indexing, right? So there's multiple vector index types, IVF, HNSW, different quantization methods. There's a full text search index, supports BM25, and then scalar indexing for filters if you want to do fast pre-filtering, JSON's support, and then we're working on geo index. So part of one of your column is lat long. You can run geo index queries on it. It's really cool. And all of this is sort of in one package as an open source data format. Okay, so now I think we went through the details. Let's put it back all together, right? So I think with Lance format, I think data infrastructure world we're now ready for agent. Right? Agents need to be multimodal. Well, Lance format helps by you can store any modality, and of course, plus the search embeddings. Right? Agents need bigger scale. So if you're storing embeddings in a vector database, a lot of times the data is in some local node, and your index has to be loaded in memory. So if you're talking about loading 1 million vectors into memory, that costs you about $200 per month. Well, if you're storing your index and your vectors on S3, right, in an object store in your Lance format, that's what, 25 cents a month? Huge difference in cost. So it makes it a lot easier for you to scale up. The incremental column addition makes it easier for you to deal with more features, especially incrementally as you go along. And the different indexes in Lance format allows you to deal with many different search modalities from just vector search, just keyword search, to various hybrid plus filters and re-rank. And then of course, like non-search workloads as well, from key value fetches for your agent state to SQL to even geo queries. And lastly, right, when we talked about iteration, excuse me, Lance format is super reproducible. So it helps you improve your agent development process by being version and supporting time travel. Okay, so at the end of the day, I think with agentic search, really what we want is really just a file, right? This is what Lance file format gives you, is just a file. And you can do all the search that you need without a separate system. So you can keep all of your data together and make that search super easy. All right, so Lance has a really large community today. We've been around for 3 years now, and as I said, we're the new open source standard. So a lot of the best frontier labs and the best tech companies in the world are now using Lance and contributing to Lance and developing on top of Lance. If you want to try it out yourself, super simple. There's an embedded library called LanceDB, where you can just say, pip install it. And for agents, we have a bunch of different tutorials. One of them is a multimodal agent, where you can just go to our docs page and try it out for yourself. Cool. So the last thing I'll leave you with is, we talked a lot about I talked a lot about how Karpathy thinks that we're not focusing on the right things. That agents will take a long time to really reach the vision that that a lot of the discourse this year around agents have been on, which is totally replacing human labor across a bunch of different industries, right? And I think I agree with his sentiment, as that I think that's actually the wrong focus. Is that rather than really focusing and making the bar about 100% human replacement, it should be about assistance. So you can automate tasks that you can automate, but if we are totally fixated on 100% human replacement, I think, it might take a long time for that to happen, or it will take a long time for that to happen. But that doesn't mean that we can't produce a lot of value along the way by saying, okay, let's pay attention to user experience. And instead of full automation, we focus on assistance and making people more productive rather than replacing them. Okay, so my VP of engineering will kill me if I don't put this up. So we are hiring across a number of engineering functions. And so if you're interested in working on data infrastructure, and especially data infrastructure for AI, you can scan that QR code and hopefully talk to us. All right, any questions?
Great talk. Just a question from a user standpoint. So outside of the ability of storing these large blobs, offering vector search and an index, what are other core feature sets that Lance, either at the file format, table format level, or even the platform level, offer that you think are kind of essential for these AI ML workloads?
Yeah, so I think number one is things like, so if you're thinking about the overall pipeline for developing an agent, right? So the Lance format and the platform is all about context and retrieval. So we can focus on that. We don't do evals. We're not we're not a model provider. We're all about managing our data. And so in terms of that data flow, right, there's a lot of focus on, okay, we have a vector database or similar database that the data goes in and you can search on it. But what about all the work it takes to get that data into the database and specifically into the format that's searchable and is valuable. So what we find is Lance and LanceDB users are actually spending a lot of energy on that process. You've got a bunch of data and like out of SharePoint, like how do you structure that data? How do you transform that data? And then how do you run these transformations at scale? So one example would be like some of the large frontier labs we work with are like, okay, a single data transformation, like I want to create a derived feature. I have like 10 petabytes of video data. This feature generation job could take like 2 days to run on like 100,000 CPUs or something like that, right? Like what if the job fails on like 1% of the rows at the end of day 2? Like, you're not going to want to reproduce that. And then you're going to want to deal with a lot of like throttling and limits. So there's a ton of sort of low-level data infrastructure that you just don't want to deal with, right? Like if you're building an agent, like you want to be talking to users, you want to be thinking about like the cognition layer and the intelligence layer. You don't want to be dealing with like job execution, resume, and checkpoints and all that stuff.
I had the next question over here to your left.
Sorry.
No worries. Curious on your perspective when it comes to multimodal search agents in terms of how future state we'd be configuring these kinds of agents between a more generalized agent versus specialized search agents that are more looking at orchestration and context sharing between them when all of our context data is stored in a single source. How does that kind of look when it comes to efficiency of specialized subprocessors?
Well, I think the interesting thing is that like when you have one system, when you have a single source of truth for that data, it becomes it makes context sharing and data sharing just a lot easier. So it gives you a lot more flexibility in how you orchestrate, how you structure and orchestrate your agents. Because like today, because the data is so fragmented, it actually is much more limiting. Because you're basically saying, I have like 3 to 5 different types of agents, and like I can only interact with these like knowledge-based systems in a particular way for a particular slice of data. And so, your choice is either having specific agent types for these different things, or introducing a ton of complexity into your agents. Whereas I think this is partly what Lance format is designed to solve is, put your data in the same place, and it's simple actually. It doesn't introduce complexity for your agent to be able to interact with any piece of it. And so overall, it just gives you more flexibilities because you want to match your agent architecture to the intelligence layer, right? How that logic should work out, not you shouldn't have to design it to match your underlying, like the limitations of the data infrastructure.
I have a question over here. When I followed the link to your hiring thing, I noticed all of your positions have senior in the title. What would somebody who, like earlier you'd mentioned agents aren't replacing us, they're giving us powers. So what would a fresh college graduate look for to get a job at LanceDB if all of the positions are already required to be senior?
Great question. I'm totally going to get whiplash at the end of this. So I think one thing you have to understand is we're a remote company. So there are, and with a remote company, there are definitely constraints on on who you can hire, how you can hire, and where you can hire. And I think for new grads or folks who are less experienced, right? It's not so much the years of experience that matters, is whether that candidate is like self-motivated and can thrive under uncertainty, right? If if like somebody is okay, I'm just gonna sit there and I'm gonna wait for a task to come to me, and like it has to be really well specified, and then I'm gonna like code it and then submit a PR. I think certainly for a remote company, that's not gonna be a recipe for success. And number two, unfortunately, like that is for a lot of hiring managers, they might be asking, if I'm hiring someone like that, why am I not just using Claude Code, right? If I have to do all of the specification and dealing with doling out of tasks and all of this supervision, I can do that with Claude Code being on the other end rather than a human. So I think it's especially for new grads and for folks who are just getting into AI, right? If you want a job in this new world, it's about like dealing with uncertainty, being self-directed and learning, and like you should be pulling context rather than waiting for people to push tasks to you.
And that is all the time that we have.
All right. Okay. Thank you so much.